Hello everyone. Let's start with our next lecture where we will cover the hypothesis testing example. In our previous lecture, we have covered the basics of hypothesis testing. Today, we will understand what is hypothesis testing using an example. Imagine you are a data scientist working with a local school that has tried a new teaching method aimed at improving students' mathematics scores. Now, the school wants to know if this new method is statistically better than the traditional. So, objective over here is to determine if the new teaching method significantly improve math score compared to the traditional method. Data here we have is mathematics test scores from two groups of students, one taught with the new method and one with the traditional method. So the scenario which is in front of us is comparing the two groups, one which is taught with the new method and one taught with previous method. So let's see the data. The new method group 1, the sample size, it means number of students in class is 30. The mean score in mathematics test is 75 and the standard deviation is 10. The traditional method group means group 2. The sample size, there are 30 different students whose mean score in mathematics is 70 and standard deviation is 12. So this new method group might be performing better. But how can you say for surety that this new method is effective and we should apply this new method, right? Let's delve deeper into the calculations. So the null hypothesis we have here, which is H0, is the mean score for the new method is equal to that of traditional method. This is our null hypothesis. Alternative hypothesis H1, the mean score for the new method is different from that of traditional method. So this is our step 1. First of all, we have to formulate the problem which is in front of us using a null hypothesis and alternate hypothesis. Now step 2, choose the significance level. Here the alpha, the significance level is 0.05. 0.05 means 95%. When I say 95%, it means 100% means 100% accuracy. 0.05 means with 95% accuracy, right? 0.05 here is, you can say like 5%. Now, step 3 is calculate the test statistic. We use the formula for t statistic in an independent two-sample t-test. T equal to mean 1. Mean 1 is actually mean for the first sample group minus mean 2 divide by standard deviation for first group square divide by n1 plus standard deviation 2 second group standard deviation square divide by n2. n1 and n2 here are number of students in group 1 and group 2. Now when we plug our values, we will get t equal to 75 minus 70 divided by 10 square divided by 30 plus 12 square divided by 30, which is equal to 1.7532. Let's move on to step 4. Calculate the degrees of freedom. Degrees of freedom for an independent two-sample t-test is calculated using a complex formula that considered sample sizes and standard deviations. In an independent two-sample t-test, the formula for calculating degrees of freedom is complex because it accounts for sample sizes and variances of both groups. The formula is here, which is in front of you. Now, using our formula, we can put all the values. We know the sample size of group 1, which is 30, mean for group 1 which is 75, standard deviation which is 10. Similarly for group 2, when we calculate this in our numerator we get this, and when we solve the denominator we plug all the values, and degrees of freedom, the DF we get after all the calculations is 56.17. Now, step 5. Determine the critical value or p-value. Compare the calculated t-statistic with the critical value from the t-distribution table. The t-distribution table which is in front of you, we know the t-value which we have calculated earlier and we know the degrees of freedom. So, in this table, if you see the shaded portion, on the left side, we have degrees of freedom. We don't have 56, so we take the nearest number, which is 60. And on the horizontal line, we will take t as 0.05, right? It is a two-tailed test. So we will get, when we do the cross, we will get a number 2. The calculated t statistics is 1.7532. For degrees of freedom 60 and two-tailed, the critical value is 2. Since the statistic value is less than critical value, we fail to reject the null hypothesis. This indicates that at 95% confidence level, there isn't enough statistical evidence to conclude a significant difference between two teaching methods. This is actually the conclusion which we derive using all this formulae and all this stuff. The p-value for your t statistic is higher than the significance level of 0.05. So in this very short example, you can see how statistics can help you take better and wise decision, and how using data and using several statistical techniques, you can present in front of anyone your findings, the story that data is saying. Okay, we will cover next topics of statistics in our next lecture. Please subscribe to this channel. Take care. Bye-bye.